Hi, welcome to CLIMA. This project is a client-linked integration of meteorological activity module. The idea behind it is to make use of the strength of Segment, AWS, Databricks, and Arduino sensors to be able for a business to react in real time to changing weather conditions. Um, in here, you can see in this project rationale that the idea here is that uh, I mean, the idea is not new, right? I mean, it's fairly new, but it's well-known fact that climate conditions affect consumer behavior strongly. And everybody's aware of it, right? Everybody's affected by weather and climate conditions. Then again, businesses are not able to react to these changes. And so there's a couple of businesses that actually are delivering some type of service. In this case, for example, weather ads and Weather Unlocked. What they do is advertising offerings based on weather conditions, which is good. But the idea here is to give that power to the businesses. Why the idea of permitting the location of the idea is that the sensors are based on the location of the storefronts. And the idea behind this is that although the technology is out there for you to be able to capture sensor data from the customer, the problem here, the main drawback is privacy issues, right? So when you pass that to the store, the front side, if you're able to capture weather conditions at the store and then match those customers that are nearby the vicinity of the store and then react and send offers based on the changes in weather conditions to the customers nearby the store. The good thing about this is that then the data is first hand, it's first party is the data that you will have about the weather conditions. So you don't have to go through the whole ropes of asking for permits or permissions to engage with customers based on weather conditions. You just need the permission to engage with them. Knowing that they're nearby the store, then you track the weather conditions in the store or nearby within the vicinity of the store, and then react. For example, if it's raining, then send an offer for umbrella. Or if it's very hot, is to then send an offer or information about weather, about skin protection, the importance of skin protection, and send an offer for creams if that's your business. Yeah. So that's basically the idea behind this project. The architecture, integration architecture considered the I'm gonna here. The Arduino sensor table is here, and so that would pick up on is a real-time clock stamp, light sensor, a rain sensor, a humidity and temperature sensor, and all of these would be passing the data over through the Arduino IDE over to AWS. I use that impulse just as a way for me to understand first the variations on the climate conditions, and so then having all that data on AWS, the idea is to be able to start modeling the data and then be able to pass it on to Databricks, and within Databricks then match it up with the data about the customers that is being processed in Twilio segment, and then capturing all the information. This is basically the tracking code that I created to be able to mainly, the most important part about the tracking code for segment was the part about the, uh, the location. So capture geolocation. So this is very important because IP addresses are not a very good indicator about location. It depends really about the connection that's being used. So that's not a very good point, particularly because you're not going to be able to match you know, then there's like the problem about matching the location of the storefront, right, where the climate conditions are being picked up on. So that needs to be based on a geolocation, latitude and longitude based parameters. So if you're able to have those two on the storefront and also on the customer side, then that's where you can actually do the matchup, right? Now the problem is that, you know, this is very long, and setting up everything is still in the process. And so last week I decided, well, I'm going to just like really narrow it down a little bit and make a lean version. So the lean version took Databricks out, and basically the idea was that then the data picked up on the store location would be processed by Arduino, send it over to AWS, and then within a Lambda function, then that would kind of is they process out the data, and so basically the business should be. I was just going to focus it on the rain because it's one single factor instead of a multiplicity of them. And so the use case focus was just that the business should be able to implement a running solution where if in the stored data point it begins to rain, so that's a variation from the standard 1024 value when it's dry, for every customer profile on Twilio segment, and that will be based on an ETL process that we ran, whose location latitude and location longitude is within a half a mile radius from the stored data point location, latitude and longitude, then update the customer profile attribute alert rain to true, and our ETL it back to Twilio segment to activate any engagement desired, right? And when the value for rain 1024 is back again to the dry condition, then is the customer profile attribute alert rain should be updated back again to false. And that way then reverse ETL it back to Twilio segment to activate any engagement desired. So I mean, the idea is to actually even be able to not only react to rain, but actually when it stops raining, right? So, oof, it stopped raining. Now here's an offer for a towel, right? So something like that. And yep, that's basically the idea behind it. Thank you so much. And sorry that this could not be finished, but thank you for the opportunity for the contest. It's a great motivator to get things going, and I'll certainly keep the project going until it's finished. And so looking forward to it. Thank you so much. Take care. Bye-bye.